So first, let's talk about a shield volcano. Okay, you guys already told me one of the key things is that we have a very broad mountain. Okay, so very, very wide with very gentle sloping sides. And that's because a lot of times what we have with these are lava flows. So they're not really explosive eruptions in terms of like what we would normally think of as scary eruptions. These are things that you can go and pay money in Hawaii and actually go watch Mauna Loa erupt. They'll take you right up to the volcano and you get to actually watch the lava spurting out of the mountain. It's kind of neat. I would definitely do that. Yeah, that part was not, but it'd be pretty cool to do it. And so again, what we're talking about here is we basically have lava flows, and then that's probably the main key I want you guys to get out of this. So we have lava flows, but really importantly, we have basaltic magma. So remember, your basaltic magma is really, really low in silica, and so we will, basically that's what creates the lava flows. It allows that lava then to flow very easy, and so we create a shield volcano. So when we think about composite volcanoes, remember we also call composite volcanoes stratovolcanoes. That's going to be the same thing, stratovolcano and composite. And you can see why we call it a composite. Notice that we have these layers of alternating types of magma. So basically it's alternating between like rhyolitic and andesitic. So we're going back and forth. But in either case, we have very steep slopes. And because we're talking about rhyolitic and andesitic, we're talking about high levels of silica. So what happens to that magma? If I have high levels of silica, what happens to the magma? It moves very slowly, so therefore it's easy to get stuck. If it gets stuck, what builds up? Pressure. And that's why we have very explosive eruptions with composite volcanoes, and it has everything to do with the silica in the magma. And so again, you guys saw the Mount St. Helens episode where literally the face of Mount St. Helens blasted outward. And again, that's because of the pressure that was building up inside it because of the high silica content. So when you think about volcanoes and where they are in the world, most of your continental volcanoes are super explosive. Okay, Vesuvius is a perfect example of that. We think about Mount St. Helens is another perfect example of that. And it's because of the high silica content. So here's an example of what's left of Mount St. Helens today. Again, right here is that face, and the original mountain used to be like this, and literally we lost the entire north face. And so it's definitely interesting when we think about volcanic eruptions. And this honestly was a hard one for a lot of the U.S. geologists. And I know they somewhat talked about this in the show, but I think they could have done a little bit more time on the people side of it. The USGS, the United States Geological Survey, they lost, I think, 4 agents in that eruption. And that's because some of them were basically thought they were safe. They were 10 miles away from the volcano. And then when it erupted, there's nowhere to go, and you got a bunch of rock coming at your face. So it's really, that was a very sad day for a lot of people. And again, because we're normally expecting the volcano to go up. So we actually had geologists that were stationed all the way around the volcano, and the ones that were over here, they didn't make it. So you guys ready to model that? I'm not really sure how well this would work, but we're going to try it. What we'll talk about is a cinder cone. And on the cinder cone, basically, we're talking about material. After the eruption, it's very loose material. If you guys want to think about a perfect example for cinder cone, think about 4th of July. And how many of you guys have those little cones, the little shower cones, right? You know what I'm talking about? And all they do is you got a bunch of sparks, right? And then those sparks, and then the cinders basically fall back down. And they pile up around the cone, right? It's exactly how a cinder cone erupts. All right, it's just loose material. It gets thrown up in the air, and then all of this right here, all the way around that, is nothing but debris. That's from the volcano itself. Now, so we do have somewhat a steep size, but again, we're talking about a very small volcano. It is more explosive than a shield, but way less explosive than the stratum. I don't know where there are any active cinder cones. I do know of a couple in Arizona. There's one that is called Sunset Crater. And that's actually what the picture is right here. This is Sunset Crater. And you can actually camp inside the crater.
And it's still explosive?
No. No, it's an extinct volcano.
What happens if it...
That would suck. Not out of the blue, we erupt and there's nowhere to go. You just say, oh, that was a fun life. And pray that the Hindus are correct and we can go back.
I just see that happening right now.
I have not camped it. I have hiked up the side of it before, and that took some energy. Basically, so Arizona is basically shaped like a big box. And
I want to go live in Arizona now.
this is basically the state of Arizona. The Sunset Crater is like up in here. So if you fly into Phoenix, it's about 3.5 hours to get there.
Like to go in the hole?
No, it's 3.5 hours to get from Phoenix to the crater. And then you have to, in fact, like right here is the visitor center.
Yeah.
And then you can kind of drive around to the different campgrounds that are around the entire crater. And then you can actually hike up into the crater.
Build a house in the middle of a volcano.
So, now, one of the things that's kind of neat is a lot of your, guys, quiet, a lot of the cinder cones tend to occur in clusters. Alright, so when we have the cinder cones, you'll see a whole bunch of them that are kind of clustered together. So it's very rare just to have a single cinder cone. Alright, so let's take a look at some here on YouTube. This is again kind of modeling a little bit before.
What are the characteristics of a shield volcano? Formed by lava flows, its wide base builds slowly over time from flow after flow of ballistic lava.
Do you
No.
trust this video?
Yes, I do trust. This is the same thing we just did.
Not really.
Yeah, that's. Don't be put in there.
I'm not quite sure if it's worth one.
You shake it.
And let's see.
Your volcano. It's steep and cones like an ice cream cone.
Ooh, ice cream sounds
Many
good.
layers of volcanic fragments, like frozen rock itself, has a bowl-like crater at the top.
There we go.
How's that dangerous?
What we were going to do is would have been more dangerous.
Yeah,
What are
we're
the
about to kill
characteristics
people.
of a stratovolcano? It's tall with a cone shape made of many layers of hardened lava and volcanic ash. The lava is viscous, meaning it cools and hardens before spreading very far.
Yeah, I'm not really too impressed with this video.
Yeah, you told me you trusted it.
Did you
Trust
watch
it.
it?
I watched the videos ahead of time.
I mean, it's a little kid.
This is what we were gonna do for cinder cone.
Oh my goodness.
I'm good.
That is cool.
So what they're showing here for the strato is actually better for the cinder cone. So you got a little bit of flames shooting up, and you can see the debris that's starting to go around the base of the volcano. And that's exactly how the cinder cones are formed.
Why can't we do that?
That stuff is called ammonium dichromate.
Oh my gosh.
Hold on. The reason why we can't do it is because it's highly carcinogenic.
Yeah.
Carcinogens? Bad for your lungs.
Then why is there a little